Hello, excuse me. Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The book contains 230 problem-solving questions. It has 174 data sufficiency questions. We have already solved every single math problem from this book. If you're interested in watching the original solutions to the problems, you will find the original solutions from day number 1 through 250. Right now we are in the process of redoing the problems and we are on page number 280. Please turn to it. Please turn to page number 280, the very first problem in the second column. Problem number 63. We are being asked, we are being told that D, we have a symbol D that denotes a decimal. We have some decimals which we are symbolizing with the letter D. The question simply is this decimal more than half, more than or equal to half? Let's see what they tell us in the first statement. In the first statement they're telling us that D, if we were to round it to the nearest tenth, it gives us 0.5. Question is this information enough for us to be able to answer the question if this decimal is more than or equal to half? Well, let's find out. For example, if we had 0.49, a 0.49 rounded to the near decimal, rounded to the near decimal would be 0.5, wouldn't it? If you round it to the nearest tenth, because we are rounding it to the nearest tenth, this number rounded to nearest tenth will be 0.5, or it could also be 0.54. Had it been 0.54 rounded to nearest tenth will also be 0.5. So what this tells us, all we know from here, D rounded to the nearest tenth, all we know from here is that the D must be equal to something between 0.45 and 0.54. It does not answer the question, is D more than a half? We do not know. It could be more than half, it could be 0.53, 0.54, or 0.51. It could be 0.48. We do not know. The first statement is not enough. The first statement by itself is not enough. AD, BCE. AD, BCE. Now if you do not know what I just did here, it's important that you watch this video. Just type in data sufficiency intro along with my name and watch that video and you will understand how to tackle these problems. We just found out that the first statement by itself is not sufficient. That tells us that the answer cannot be A or D. Answer would have to be B, C or E. Just give me 1 second, just a quick break. Let's look at second statement. In the second statement they tell us that the D rounded to the nearest integer, D rounded to the nearest integer is 1. Well, if D rounded to the nearest integer is 1, then D would have to be between 0.50, between half and 1.49. Anything in this range between 0.5 and 1.49, if you round it to the nearest integer, 1.49 rounded to the nearest integer will equal 1, and 0.5 rounded to the nearest integer will also be 1. So yes, that does answer our question. The question was, does this decimal happens to be more than or equal to half? The answer is yes, it's got to be somewhere between half and 1.49, so it's definitely more than half. Second statement by itself is quite sufficient. The answer is B. Second statement by itself does the job quite nicely. Let's look at the next one, shall we? Number 64. These questions are not sometimes these questions are not that difficult. They just require some thinking that is not something that we do on an ordinary multiple choice problem. Do you understand? These are different type of questions. Number 64. The question is how many integers are there between R and S. R and S are two integers. And the question is, how many integers lie between these two integers? Let's see what they tell us. In the first statement, they tell us that the difference between s and r is 10. Well, that's quite straightforward. If we know their difference, then obviously we can count how many lies between r and s. The first statement does the job quite nicely. We don't actually have to do anything to figure that out. We just by looking at it, we can tell. But if you wanted to be sure, and if you wanted to put in extra time, it's very simple. Just plug in some numbers here. So let's say 15 minus 5. So all the integers that fall between 15 and 5 will be counted here. So that will be 6, 7, 8, 9, 10, 11, 12, 13 and 14. There you go. There are 9 integers that fall in that range. S minus r is 10. If s happens to be 15 and r happens to be 5, there will be 9 integers that will fall here. The question is, how many integers fall between r and s? The answer is 9. But this was unnecessary. We don't actually have to figure out how many lie there. These questions are called data sufficiency. As I always remind you, we simply have to be able to realize that that was sufficient data. The first statement by itself does the job quite nicely. AD, BCE. AD, BCE. Since we just established that the first statement by itself does the job quite nicely, we know now that the answer cannot be B, C or E. It would have to be either A or D. Let's look at the second statement. The second statement tells us that there are 9 integers between r plus 1 and s plus 1. What the hell? It's the exact same information, of course. If we know how many integers there are between r plus 1 and s plus 1, then the number of integers that lie between r and s can be the exact same number. Obviously, because you're simply picking up the series and shifting it by 1 unit to the right. Instead of starting with r, we're starting with r plus 1, and instead of ending at s, we're ending at s plus 1. It's the same series. It's been shifted 1 unit to the right. That's all it is. If we know that there are 9 integers between r plus 1 and s plus 1, then there would have to be 9 integers between r and s. Second statement by itself also does the job quite nicely. The answer is D. We're not going to actually waste our time to actually plug in numbers and so forth. That'll be too silly. And if you like, you can do it yourself actually. Number 65. Let's move on. Number 65. In number 65, we are told that the total number of... Oh, actually, we are not told anything. Number 65, we are not told anything. The question simply is the total number of coins that Bert and Claire... What is the total number of coins that Bert and Claire have? Alright, so we have to figure out the total number of coins. Total number of coins B and C have. That's the question. How many total coins they have? Now listen, before we continue this problem, I want to make a note of it, and if I don't do it right now, there's a good chance that I might forget all about it. Here's what I would like you to do. I would like you to compare this problem to problem solving question number 64 on page number 161. Problem solving question number 64, 161. Watch that video. We have already done this problem. Watch that video. You can always search by the page number. Just type in P161 and you will pop right up without the period. I don't know why I put the period here. And it will pop right up. Make sure you watch this video and compare this problem to that problem, and you will get something out of it. Let's continue. Let's see what they tell us, alright? In the first statement they tell us that B has 50% more coins than C. In other words, the number of coins that B has is 1.5 times the number of coins that C has. Well, that you can clearly see is not enough. That by itself we cannot figure out how many total coins are there, because there are 2 unknowns here and only 1 equation. First equation by itself is not sufficient. It's not worthless. This information is not utterly useless. It might come in quite handy, but it is not sufficient. Data sufficiency. You understand? A, D, B, C, E. Since we just established that the first statement by itself is not sufficient, we know now that the answer cannot be A or D. It would have to be B, C or E. Let's look at second statement. In the second statement, they tell us that the total coins that we have is between 21 and 28. Again, simply knowing that total happens to lie between 21 and 28 does not enable us what the total number of coin there is. Obviously, all we know is that between 21 and 28. Second statement by itself does not do the job either. Answer cannot be B. Answer cannot be B. Let's put the two together. When we put statement 1 and statement 2 together, listen very carefully, that is where we need to put our thinking cap on. Do you understand? Let's see what happens when we put the two together. Knowing that B has 50% more coins than C, that tells us the total number of coins that we have must be the number of coins that B has plus the number of coins that C has. B happens to have 1.5 times C, and of course the number of coins that C has is C. So the total number of coins that we have happens to be 2.5 C. Keep listening, okay? Keep listening. Now, what we need to understand here, which is why I want you to watch this video here, is that sometimes, not always obviously, but sometimes the nature of the problem is such that we need to pay attention to the reality of the things. For example, if you're talking about boys and girls in the problem, or if you're talking about a ratio of students to teachers, or if you're talking about ratio of blue cars to red cars, or ratio of daffodils to roses in the garden, or for that matter, number of coins, the nature of these problems is such that they need to be integers, they need to be whole numbers. We cannot have a 1/3 of a coin. We cannot have 1/3 of a coin, and that intuition has to be there. You have to understand that. What does this tell us? What does this tell us? Knowing that the total number of coins that we have, has to be some multiple of 2.5, what does that tell us? We know it's between 21 and 28. Well, between 21 and 28, there is only one number. There is only one integer between 21 and 28 that will be exact multiple of 2.5. And that answer, of course, would be 2.5 times C. Voila! 2.5 times 10, rather, is what I meant to say. 2.5 times 10. What I meant to say is that total number of coins that we have has to be 25. There is only one number. Let me re-say it. I did not say it properly, I think. I'm not sure. There is only one number that lies between 21 and 25. There is only one number that lies between 21 and 28, rather. There is only one number that lies between 21 and 28 that happens to be evenly divisible by 2.5. And that number is 25. So here C must be 10, because 2.5 times 10 will give us 25. C must be 10. C has 10 coins and B must have 15 coins. So the question was, how many coins do we have together? Putting the two statements together and realizing that the total number of coins needs to be an integer, therefore the fact that total happens to be 2.5 times C, then the total will have to be 25, because 25 is the only number between 21 and 28 that is evenly divisible by 2.5. The answer is C. The total number of coins cannot be 22 or 23 or 26 or 27. It's just not possible. Do you understand? You cannot divide those numbers by 2.5. Let's go on then. Number 66. Number 66. In number 66, we are told that we did the survey of 200 people. 200 people are surveyed. We are told that 30% had loans, and we're going to represent those people by letter L. We are also told that 40% had scholarship, and we're going to represent those people with letter S. The question is, what percent had neither? What percent had neither? We need the room obviously, so I have to erase this part now. I do not know why I have this urge, this uncontrollable urge, to point out the bloody obvious. But that is what I do. That is my forte. Well, the very first thing we're going to do here, listen to me. I find it very annoying having to do with 200 bloody people. And that they give you percentages and you have to spend the time to figure out twice the amount. It's not a big deal. 30% of 200 is not a big deal. But why the bloody hell should I waste our time to figure out? Let's just convert it. Let's just kill 100 people, shall we? Let's just kill 100 people. Let's just kill 100 people and we'll forget about the percentages. Okay, so we created our own problem, customized the problem. So we surveyed 100 people, 30 of them had loans, 40 of them scholarships. The question is how many had neither? That's it. Let's see what we can do, shall we? It doesn't change the problem. It's still the same problem. It's just that we have only half as many people. 200 is annoying. Do you understand? Let's look at number 1. It's okay. Learn to cut strings. Learn to cut strings. Do not be a bloody puppet. Do you understand? You mustn't dance to their tune all the time. Take some liberties. As long as you do it in a reasonable manner. As long as you don't go bonkers. You understand? First statement tells us that 25 had S but no L. 25 had S but no L. 25 has, well, there you go. We know that there are 40 of them who had scholarship. So that implies, since there are 40 of them, we were told that there are 40 people who had scholarship, and here we are told that 25 had scholarship but no loan. That implies that 15 must have had both. Must have had both. That's the logical conclusion, because 40 people we know altogether had scholarship. If 40 had scholarship, out of the 40, 25 had scholarship but no loans, we are told. Well, there must be 15 people who must have had both. Now, if you like, if it makes it easier for you, if it makes it more comfortable for you, you could actually use a tool what is known as a Venn diagram. It only takes a couple of seconds to draw the Venn diagram. Here's what we're dealing with. We have here we have our loans, and here we have our scholarship. In the beginning we are told that 30 of them have loans. 30 of them have loans and 40 of them have scholarships. This is how this story begins. We just found out through our work there must be 15 people who had both. 15 people must have had both. So that 15 now goes here. As soon as we put the 15 in the common area there, we have to go and adjust these figures. So this 30 becomes 15 and this 40 becomes 25, which tells us that 25 people had only the scholarship. This tells us 15 people had only the loans and 15 people must have had both. 15 plus 15 is 30. 30 plus, let's put it here. So only loan we know now is 15. Only scholarship we know now is 25. And both is 15 right here. 15 plus 15 is 30. 30 plus 20 is 25. 30 plus 20 is 50. And 50 plus 5 is 55. 55 is what we come up with total. But we are told that 100 people were surveyed. Well, if 100 people were surveyed and 55 people fall in the category where they had one or the other or both, then that implies there must have been 45 people who had neither. There must have been 45 people who had neither the scholarship nor loans. First statement does the job quite nicely. First statement does the job quite nicely. We need the room here. A, D, B, C, E. Since we just found out that the first statement by itself does the job quite nicely, we know now that the answer cannot be B, C, or E. It would have to be either A or D. Let's look at second statement. Second statement tells us that half of those who had loans, also had scholarship. Well, the problem tells us that 30 of them had loans. Well, if 30 of them has loans, 30 had loans, that implies that 15 also had scholarship, which this 15 also means this 15 had both. Once we establish that the 15 of them had both, then the story is same as before, nothing changes, we just set it up as before. Here we go, loans is 30, scholarship is 40. We just found out that the 15 had both. We put 15 here, same story as before. As soon as we put the 15 in the middle, this has to change to 15, this has to change to 25. We add up these figures and we find out that this adds up to 55. But since this adds up to 55 and there are 100 people altogether, 45 must have had neither. Answer is D. The story is the same as before. Do you understand? Let's go to the next one, number 67. The penultimate problem. Number 67, give me a quick break. Number 67. Question is, what's the value of integer n? That's all. Very simple, very straightforward question. Let's see what they tell us. Statement 1 tells us that n times n plus 1 equals 6. Now do not be hasty. Do not be hasty. You must always be alert. Always remember that God created two kinds of numbers. Forget about your math teachers. Forget about the math teachers. All these math courses that you took as a young schoolboy or young schoolgirls back in the old days, in the school time, many moons ago. In those days, we were told that there are even numbers, there are odd numbers, there are prime numbers, there are rational numbers, there are irrational numbers, and there are this number and that number. Forget all of that. As far as the exam is concerned, the numbers come in only two flavors. Numbers come in two flavors, nice and nasty. They only come in two flavors, nice numbers and nasty numbers. It is the nasty numbers that you have to keep in mind. The nastiest of all is 0. Then we have to worry about 1, and then we have to worry about negative, and then we have to worry about fractions. You must always contemplate these four possibilities. So don't be hasty. Don't just say here that if this is the case, then it must be 2 times 2 plus 1 equals 6, and that's it. And in your haste, you might say that the first statement by itself is enough. It is not enough. You must always contemplate all the other possibilities. 0, of course, does not apply here. 1 does not apply here. How about a negative? What happens if n happens to be a negative number? If n happens to be a negative number, if n happens to be negative 3, then negative, excuse me, negative 3 plus a 1. If n happens to be negative 3, then negative 3 plus a 1 will give us negative 3 times negative 2, and negative 3 times negative 2 is positive 6. So this statement by itself is not enough. All we get out of this statement is that n is either 2 or negative 3. This does not tell us what n is. N could be either 2 or negative 3. The first statement by itself is not enough. Only those people who do not worry about negative numbers will sit there and think that this statement is enough. It's not enough. We just found out that the first statement is not enough. AD, BCE. Since we just found out that the first statement by itself is not enough, we know now that the answer cannot be A or D. It would have to be either B, C, or E. You understand? Let's look at second statement. Let's look at second statement. I need the room. Maybe we can do it here. Remember, nice and nasty numbers. Nice numbers and nasty numbers must always contemplate what would happen, the eventuality that we may encounter a 0 or a 1 or a negative number, negative quantities, or fractions. Something between negative half and a half. Do you understand? Or rather, not negative half and a half. Well, I meant to say between negative 1 and 1. The fractions. You understand? Or to be more precise, between 0 and 1, because we already talked about the negative numbers. Let's look at second one. 2 raised to 2n, we are told, is 16. Oh, this is very straightforward actually, because 16 can be written as 2 raised to 4. This is too simple, which means 2n, we are told, has to equal 4. If 2n equals 4, then n will have to be 2. n is 2. Second statement, from the second statement we know for a fact that n has to be 2 and cannot be -3, because the -3 would not have worked here. N has to be 2, n has to be 2. Not that -3 would be, not that we would even think about -3, because when we get to second statement we have to erase our memory everything that we learned from the first statement. You understand? So here second statement by itself is enough. We know for a fact that n would have to be 2. That's the only value of n that would work here. 2 raised to 4 equals 16. Second statement does the job. The answer is B. The answer is B. Let's go on to the last problem, number 68. It's been a long video. Number 68. We are told that 3 machines do a job in 24 minutes. So we have 3 machines and we are told that they do a job in 24 minutes. The question is, how long will K take? Machine K, if it were to work by itself, machine K working by itself, how long will it take? Let's see what they tell us. In the first statement they tell us that M and P can do the job in 36 minutes. If M and P were working doing the job, they can do the job in 36 minutes by themselves. What that implies to us, that tells us that implies that in 12 minutes, if it's 36 minutes, that implies that M and P can do definitely can do 1/3 of a job. M and P can do 1/3 of the job in 12 minutes. Why not? If they can do the job in 36 minutes, if they can do the entire job in 36 minutes, then obviously they can do the job in 12 minutes, because the assumption is always there that they are working at a uniform rate, obviously. That in return implies that M and P can do 2/3 of the job in 24 minutes. Okay, keep listening. Okay, we need the room. We're going to erase all of this thing. And 24 minutes is how long they've been working, all 3 of them together. But we just found out that in 24 minutes, M and P can do 2/3 of the job. Well, if M and P can do 2/3 of the job in 24 minutes, that in return implies that K must do 1/3 of a job, of the job in 24 minutes. It must do 1/3 of a job. The K must do the remaining 1/3. K must do the remaining 1/3. This is the remaining 1/3. Remaining 1/3 of the job in 24 minutes, because in 24 minutes these two of them together can do 2/3 of the job. Well, if K can do 1/3 of the job in 24 minutes, the question was how long does K take? K must take 24 times 3. Because it can do 1/3 of the job in 24 minutes, so it can do the whole job in 24 times 3. The first statement by itself does the job quite nicely. A, D, B, C, E. Since we just established that the first statement by itself is enough, we know now that the answer cannot be B, C, or E. It will have to be either A or D. Let's look at second statement. Let's put second statement here. Second statement tells us that K and P together can do in 48 minutes. Now the problem with the second statement is that now we know that K and P together, working together, they can do the job in 48 minutes, but there is no way to separate the K from the P. There is no way to separate it. Here we were able to do that because they gave us the information about M and P, leaving the K alone by itself, so we were able to separate it. Here, knowing that K and P can do the job in 48 minutes, there is no way to figure out how long K will take to do the job. There is no way. We know that together they can do in 48 minutes, but we have no way of separating the K from the P. The second statement does not do the job. The answer is A. The answer is A. That is all. I will see you tomorrow, okay? Bye now.